Hello. So we are solving prefix sum and hashing. So these are five fleet code problems, and this is pattern number seven. So in this list that I generated through GPT, there are 75 patterns, and we are solving each of them one by one. So today in this video, we will be solving pattern seven, prefix sum and hashing. So the first problem is 560. Okay, problem number 560. Okay, I'll reset this. Given an array of integer nums and an integer k, return the total number of subarrays whose sum equals to k. Okay, given an array of integer nums, this is the problem, right? Prefix sum and hashing 560. Okay, given an array of integer nums, this is the array of integer and an integer k. Okay, return the total number of subarrays. We have to return the total number of subarrays whose sum is equal to k. So 1 and 1, it's equal to 2. So this is one subarray, and I guess this is another subarray, even though they have the same elements, but since their starting index is different, we are considering them different subarrays. So that's why we have two subarrays here. And in this one, 1 2 is subarray and 3 is another subarray. So there are two subarrays. So normally in this kind of questions, if you have been asked to create about subarrays, right? Uh, One thing that you should know is there are n into n plus 1 by 2 subarrays here. How do I know this number? So if you see here, there are three subarray of size 1. One is a subarray, 2 is a subarray, 3 is a subarray. So three subarray of size 1, then two subarray of size 2, and last one subarray of size 1, which is 1 2 3. So which is, it's like n plus n minus 1 plus n minus 2 and so on. So which is equal to n into n plus 1 by 2. So the worst you can do is you can try two for loops and do it in odd and square, and we'll see if we can solve it better way. One thing that just comes to mind is, let's say 1 2 3. If I take prefix sum, it's like 1 3 6. Now if you look at this prefix sum 136, and these are the, okay, what we should do in, we should hold them in a map. 1 is one time, 3 is one time, and 6 is one time. Now if they're asking for whether when k is equal to 3, so Isabel is starting at 1 can have k equal to 3 only in this particular case. Now let's say we don't include 1 and we see for sub is starting from 2 or 3. Let's say 2 3. Then from 2 we have, in this prefix sum we have already added 1. So what we need to do is, when we are checking for k, we should check, we should modify k but not the prefix sum, prefix hash. let's say for 2 and 3, if we want to find uh, since first element was 1 and now we are not including it, what we should do is we should search for k plus prefix k plus 1 in the sub array after removing the first element. We'll remove it and then we'll search for k, which is 2 plus 1 3. We want to search for, we will search for 4, then we will find a sub array which after removing first element will have sum of 3. So we'll search for k plus prefix after removing the first index hash, and similarly we will do this way. And since even though there are negative elements, right, even though there are negative elements, this thing won't impact because we are doing k plus prefix. So even the initial elements, let's say those are their prefix sum is negative, then what they are doing is we are making we are searching for a hash which is prefix larger than k, because prefix we are removing from the initial elements and prefix was added. So let's define vector int prehash, yeah, prefix sum value which is initially equal to 0. Now you want to store, so num size less than 10 ki power 3, so it won't overflow probably. Now we have prefix sum, which is like, okay, we talked about unordered map, right? it doesn't exist. If it exists, we add one to it. Now in 1 2 3 we have this thing ready. Initially, in the first loop, we'll again set value to 0. In the first loop, when value is 0, what we want to search is if value plus k is present. Value plus k present means value is 0, k is 3. So if 3 is present, 3 is present here. Yeah. We have to return total number. If it is not equal to, means if it is present, create an answer variable and okay. Mm, so in 3 is present one time. So, but after this value is num say, right? Value is 3. So what we have to do is, yeah, value became 3. And from prefix sum, we have to remove value one time, because now one, since we are not considering one this time, one has this has just went away, and in the further elements we are searching for value plus k, which is like 1 plus 3. We are looking for 4, because if it is 4, then it tells you that after removing 1, even after removing 1, there is some subarray whose sum is equal to 3, but here you don't find 4. And then you add 1 plus 2 3. Now you remove 3, you see 3 plus 3 6. 6 is present one time. 6 is present one time. This is the answer. Let's try to run it once. We created an ordered map. Then we are adding prefix sum here, and if prefix sum value is is not present, then we are assigning it 1. If it is present, we are adding on to it. And then, because we are only concerned about count, then again for the last element also, right, it works, because If it's 0 1 2, I is 2, then 1 का सम 1 तक का सम 3 हो गया है, तो और 3 भी जा चुका है यहाँ से, एंड now we are only looking for 3 plus 3 6. Yes, this should work. Well, we can look at the next question. 1248, count number of nice Saveris. Yeah, this one works. I'll reset this one. So this is protein check. 1248, we are given an integer array of nums and then k. A continuous array is called nice if there are k odd numbers on it. So there is one, yeah, one odd element. Now it's we got two odd elements. So the array between these two and of the odd elements, right? This has to be part of the subarray anyway. But these even elements, it is our choice. They can be part of the array and they can't. Like it's up to us. So if you look at it, it's like you can either escape all of these. You can take one of these. You can take two. You can take three and form subarrays. So there are four choices, and here as well there are four choices. So there are 16 subarrays. So what you should understand is you need to know what is your starting point, and either before the end of the array or before you find a new one, you need to settle the previous ones. In this case it would be 2 into 4 8, because either you can take this one or you don't. So there are two choices here. There are four choices on left side. So 2 into 4 8, and then again here you have three choices and two choices 6. So 8 plus 6 14. We need to maintain uh, in an array that what is the leftmost odd element index, because if we can maintain leftmost odd element index, then we can find 3 in this case, and that there are 3 options here and there are 4 options here. So if we know leftmost element, we can do it. And for rightmost, we we can take idea from current index. So one thing that is sure is we need a vector which is for storing leftmost index. Left alt index. And initially we can give it -1 because let's say if it is 3 -1 4, then it can give us 4 options. And this odd index initially start from 0, 1. 1 would be the first element that we would enter. We want to count the number of nice surveys ultimately. So and we want to return answer. If nums I is odd, only then we care, otherwise we don't even care. If it is if odds are equal to k, then only we want some. So what we want is we want left counts, let's say LCs, we want RC, and if it is not odd, this will be calculated using I minus. This thing is easy first. And OI will only change once we have tackled that part. Since odd is already equal to k, we are skipping the leftmost element, and odd is being maintained at k even after find a new odd element. But this thing, right, we need to add odd element nonetheless. Here, let's say I is 10th index, and on last element we have 5 indexed, so 10 minus 5, so 6, 7, 8, 9, 10, 5, which is good. One thing that we need to care about is what if array ends and we don't find the next one. So in cases if I is nums dot size minus 1, we need some special consideration here. So if odd is already k, which in this case is it is, and nums I move to 0, then LC would be same, which is 4 in this case. And RC would be I minus this time there will be plus 1 as well, because the last index is this time can be considered. In the previous time it was not considered. Okay, and let's say solving it. Then when you came inside this loop, odd was k, you counted left, which was this thing 4, you count right, which is this part 3, and we have 4 into 3, 12. And since even now this is last element, we have to take care key odd, because odd is still k, right? And nums is 1. Then LC would be same. Why LC would be same? Because this time LC would be this thing. 3, 6 minus 3. OI we already increased here. That's why OI was initially 0 because now OI is 1. So we are checking this thing. RC would be, there is nothing on right of it, right? So one answer would be, okay, looks good to me. Here, let's take an example what's happening. Which test cases? This 246 had an issue, right? Okay, we only want it to go inside if odd is at least greater than 0. Because if it odd is greater than 0, then with guarantee you can say कि we post something inside left odd in, and it this thing won't give an error then. Yeah. Now we are not getting the buffer overflow error, but we are getting some logical errors. Yeah, we'll look into it. So for 246, we are definitely getting 0. These things they are not working. We are outputting 3, but expected is 2. Let's look at this problem. These are the only two solutions. Why are we outputting 3? So you see, when I is 3, it is odd. It's still not equal to k. We added now it odd become equal to k. We added I in the left odd in. Here left odd in is now -1, 0, 1, 3, and OI is still equal to 0. Now I is equal to 4. Yes, it's 1. Odd is equal to 3. Yes, odd is equal to 3. If it odd is equal to 3, left odd in y plus 1, 0. Else is 1. RC 4 minus 3, 1. Answer is 1. Y now became 1. Okay, and we pushed back 4 as well. Now last element, and odd is definitely greater than 0. LC is 1 minus 0, 1. LC is still 1. RC, okay, it won't go inside this one, it will go here. Three minus 4 minus last element pushed, which is 3. Let's try to figure it out without this thing. Okay, now, okay. When I is 4, odd is equal to 3. Y is plus 1 is 1. y plus 1 is 1 and left origin is 0. 0 minus minus 0 minus 1. 1 else is 1 or c I is 4, 4 minus last element 3, 4 minus 3 is 1, answer is 1. Y now increased to 1, I now become this. I is equal to nums dot size minus 1 and odd is greater than 0, we came inside LC. I'm not able to figure it out, so I will. If I enter this once, but anyway. Oh, I only increased one time, right? Oh, oh, I had to hit 0, right? I didn't look. I was supposed to look there. I thought y is 0. This one is done. 523 continuous subarray sum. It's pretty late, so I think we will only solve this problem. So we are given this integer array and k is 6 and we have to find true or false. We have to find in true or false. So in these questions, if you are in an interview, just returning true or false simply can solve at least half of the test cases if you are not able to figure out any solution. And here this one is similar to the problem that we faced where we were asked to find number whose sum is exactly equal to k. We were asked to find the count of those things. In this one we are asked to find just true or false, so it's similar. But here one thing is it is asking if it is divisible by k sum. So we can use mode here. What we'll do is we'll not store their prefix sum, but we will store their mode. mode of the prefix, and if that mode is zero starting from this thing, then you can be sure that whenever it is zero, it is zero now, I think 23, 25, 31, 35, 42. It is zero. 42 mode 60, right? So last element will have its mode zero. So you can say that this is the array, but it's saying at least two element has to be there. So it can't be that first element would be always would always have 23. If it is 6, its mode would always be 0, so that won't count. So one thing is, if I is not 0, let's say some prefix, some value is the end value, and value is 0, then we return true. Another thing is in the prefix sum game, here let's say 23 to 4. 23, the prefix sum hash should be 5, 1, 5. So here, this is one of the answer anyway, because this is 0, right? And at the end we return false. But one thing we can notice is if we check any other occurrence of 5, if we just get any other occurrence of 5, we can surely say कि there has been some addition which was a multiple of 6, which is 2 plus 4. Even here we can say same thing. So if so, one thing is value is initially equal to 0, right? Yeah, value is initially equal to 0, and you want One thing you should notice, there is 6 here, 20 and 3, 20 and 6, 23 and 6, 29, and we'll get 5 here. So if these are nearby numbers, what we should store here is when did this prefix came. So in this case of 5, it would be 0. And if the next 5, it's greater than 1, which can be this way, then you can say that this is an answer. But this is not an answer. Neither is along this one. Can I submit? Something is wrong with our solution. should check it here. Yeah, there is no meaning checking it first. Yeah, done. So that was the third question.